So for page 59, you will title it Horizontal and Slant Asymptotes. Another term they use for slant asymptotes is oblique asymptotes as well. You're going to need the two sheets that look like this, so go ahead and pause the video, cut them out, and paste them in here so that you can prepare your notes. Okay, so first thing, to find horizontal and slant asymptotes, you will find the degree of the numerator and the denominator. So you'll take the degree of the top, you'll compare it to the degree of the bottom, and you have three different cases to look at as to what will happen. Either the degree of the numerator will be equal to the degree of the denominator, the degree of the numerator will be less than the degree of the denominator, or in case 3, the degree of the numerator will be bigger than the degree of the denominator. Each of these cases has a different situation for your asymptotes. So let's look at case 1. I have a picture example to go along with case 1. And this is the case in which the degree of the numerator is equal to the degree of the denominator. So this is my example. It says y equals x squared minus 1 over x squared minus 2x minus 3. Go ahead and write that in there for me. And so if I look at the degree of the top, this polynomial has a degree of 2. That's the highest exponent. The degree of the bottom for that polynomial also has a degree of 2. And so what we do is the horizontal asymptote then is going to be at y equals the ratio of the leading coefficients. And so the leading coefficient of the top is 1. The leading coefficient of the bottom is also 1. So in this particular example, the horizontal asymptote is y equals 1. And I've highlighted that and I've labeled it as well. Now, in the case of case 2, where the degree of the top is less than the degree of the bottom, I don't have a picture example for this one. You are actually going to have a horizontal asymptote again, but this time it will be at the x-axis at y equals 0. We'll see an example of that in class. And in the third case, where the degree of the top is bigger than the degree of the bottom, you actually don't have a horizontal asymptote at all. You have what's called an oblique or slant asymptote. I put OA for short. And so this example that I have here is y equals 3x squared minus 2x plus 1 over x minus 1. Go ahead and write that in. The degree of the polynomial on top is again 2. However, the degree of the polynomial on the bottom is now 1. And since the degree is bigger at the top than at the bottom, again, you do not have a horizontal asymptote, but you have an oblique asymptote. And so what you do to find this one is you actually use long division. The oblique asymptote will be at y equals whatever the quotient is of that long division. You ignore the remainder completely. So in this example, since x minus 1 is in the denominator, I'm going to use long division, or in this case, I can actually use synthetic division. If I were to set this up using long division, 3x squared minus 2x plus 1 would go underneath the symbol as the dividend, and x minus 1 would go on the left side of that as the divisor. But because of the form x minus a number, I can actually use synthetic division instead. So that's what I'm going to do. I'll put 1 in the box. I'll put 3, negative 2, and 1 to the right. And then I'll start my synthetic division. When I do that, I end up with a remainder of 2. I ignore that. I only want the coefficients of the quotient, which are 3 and 1 in this case. This quotient would be y equals 3x plus 1, and that's actually where the oblique asymptote would be located. So in order to graph that, I would go to the y-intercept, which is 1 on the y-axis. I would go up 3 units, 1, 2, 3, and I would go right 1. I would do it again, 1, 2, 3, and then I would go right 1. And then you would connect the dots using a dotted line to indicate the oblique asymptote. We'll do more examples in class, but that is it for this page.